So, what actually happens when space itself literally breaks? You know, when time just stops dead in its tracks and light, the absolute fastest thing in the universe, gets completely trapped? Well, welcome to today's Explainer. I am so pumped to guide you through this today because we're diving headfirst into one of the most terrifying, absolutely mind-bending phenomena in the entire cosmos.
Think about it. For centuries, black holes were just pure theory. They were these invisible cosmic monsters that pretty much defied every single law of physics we thought we had figured out. Imagine a place in the universe so incredibly extreme that our entire understanding of reality just shatters. That's exactly our focus today. We're going to explore exactly how these invisible giants actually managed to swallow light itself, how we finally, incredibly, managed to capture one on camera, and why these very anomalies might just hold the ultimate secrets to our universe. All right, let's dive right into this. Section 1. Anatomy of a black hole. The death of a massive star. To really wrap our heads around how these monsters operate, we first got to look at how they're born. A black hole isn't just some empty void, right? It's the remnant of a dead star. And not just any star. We're talking about a heavyweight, a star at least 20 times heavier than our own sun. When a star like that reaches the end of its life, it goes out in this incredibly violent, brilliantly bright supernova explosion, and its core just collapses inward on itself. To put that into perspective, first imagine taking the entire Earth and squishing it down into the size of a tiny glass marble. Wild, right? Okay, now imagine taking our entire sun, which is 1,000,000 times bigger than Earth, and squeezing that into the exact same marble. That absolute, absurd level of density is exactly what creates the unstoppable gravitational pull of a black hole. And that ultimate gravity, it creates a boundary that we call the event horizon. Basically, this is the absolute point of no return. As you get closer and closer to this boundary, the gravitational pull gets exponentially stronger. Once you cross that line, you're trapped forever. Literally nothing can resist it. But you might be wondering, how exactly does this boundary manage to trap light itself? Like, why is a black hole truly black?
Well, it all comes down to the mechanics perfectly captured in this idea. Escape velocity exceeds the speed of light, and nothing, absolutely nothing, travels faster than light. See, to escape the gravity of any object, you have to travel at a certain speed. But once you're past the event horizon, the gravity is so overwhelmingly intense that the speed you need to escape is actually faster than the speed of light. And since the universe has a very strict cosmic speed limit and nothing outpaces light, the light itself just gets swallowed up. It's absorbed entirely, with absolutely zero light ever bouncing back to hit our eyes. That right there is the core mechanic of how a black hole turns invisible. Section 2. Photographing the invisible. Making the incomprehensible visible. For decades, this had scientists completely baffled. I mean, how do you prove something is there if you literally cannot see it because it swallows all the light? Well, on April 10th, 2019, scientists shocked the entire world by pulling off the impossible. They released an actual image of a black hole located a staggering 55 million light-years away from Earth in a galaxy called M87. To pull off a shot like that, they had to link up telescopes all across the planet, essentially turning the entire Earth into one giant unified observatory. But wait a second. If light can't escape a black hole, what exactly were we even looking at in that famous photograph? Actually, we didn't photograph the black hole itself at all. We photographed its accretion disk. This is that intensely glowing ring of superheated gas and cosmic dust that's actively spiraling into the black hole. It's whipping around at nearly the speed of light, heating up to millions of degrees, and just blasting out massive amounts of radiation. We literally took a picture of that glowing light in its final chaotic moments, right before it crossed the event horizon and got completely swallowed into the dark. Just to process this single image, they had to sift through a mountain of data. We're talking an amount equivalent to literally all the videos ever uploaded to YouTube. And when it was finally unveiled, the whole scientific world just fell silent. Because Einstein was right. The image confirmed his 1915 equations for general relativity flawlessly. The shape, the glow, the exact way the light warped right before being swallowed, it was a totally perfect match. We literally made the incomprehensible visible. But hey, the discoveries definitely didn't stop there. Cut to 2022, and that very same team proved these monsters are lurking right in our own cosmic backyard. They photographed Sagittarius A-star, which is the supermassive black hole sitting directly at the center of our very own Milky Way galaxy. To put its size into perspective, its mass is a staggering 4 million times greater than our sun, and it's just been sitting there, silently running the show at the heart of our galaxy this whole time.
Section 3. Paradoxes at the Edge, where physics breaks down.
Now, finding and actually photographing these black holes was a massive triumph, for sure, but it honestly opened up a terrifying Pandora's box of questions. The more we learn about how they swallow light, the more our standard, everyday rules of physics just kind of break. And the biggest question of all, where do black holes actually lead? Like, once light and information gets swallowed past that event horizon, what actually happens to them? For a long time, physicists just assumed anything falling in was destroyed, just completely erased from existence. But that violates some incredibly deep laws of quantum mechanics, creating what we call the black hole information paradox.
Adding a whole new layer to that paradox is this monumental discovery made by Stephen Hawking back in 1974. He used math to prove that black holes actually aren't 100% black. They actually leak. They emit these tiny, tiny amounts of energy, which we now call Hawking radiation. Because of this slow radiation leak, black holes slowly evaporate and eventually they just die. So if the black hole dies and fades away, where does all that trapped light and information go? Honestly, we still don't have the answer.
And if we follow that swallowed light even further inward, past the violently glowing accretion disk, past the terrifying point of no return event horizon, we hit an even bigger question. What exactly lies at the absolute center of a black hole? Well, according to our current grasp on physics, the answer is the singularity. It's defined as a point of literally infinite density, where all of that mass is compressed into absolutely zero volume. When scientists try to crunch the numbers and calculate what happens here, the math literally breaks. I mean, it's the real-world cosmic equivalent of trying to divide by zero on your calculator. Our entire understanding of reality just completely fails at this exact point. But, because the math breaks down so dramatically, it actually kicks the door wide open for some pretty wild theoretical possibilities. For instance, what about wormholes? Einstein's equations actually leave room for them. These bizarre tunnels through space-time that could act as cosmic shortcuts, connecting incredibly distant parts of the universe. Could the immense gravity well of a black hole actually be an entrance to a wormhole? The math says maybe, but whether a person or even a ship could survive that journey is a completely different story. In fact, surviving the trip might be totally impossible before you even get inside. Take a look at this wild hypothesis from 2012 called Hawking's firewall. Some physicists suggested that the event horizon isn't just this smooth, dark, quiet boundary where light smoothly gets swallowed. They think it might actually be a literal wall of infinitely hot energy. So crossing it wouldn't be a quiet slip into the dark, you'd be instantly incinerated into ash. The mere fact that top scientists are still actively debating whether you'd quietly float inside or just explode on contact really shows you just how much we still have to learn.
Section 4. Why black holes matter. Grounding the cosmic physics.
Now, at this point, you might be thinking, okay, this is cool, but why should we, sitting safely here on Earth, even care about these distant space monsters? Well, understanding them is actually completely crucial for humanity's long-term future. There are 4 massive implications here. First up, safety. As humanity inevitably expands further out into space, we absolutely have to map out these gravitational anomalies so future spacecraft aren't just completely torn apart by warped spacetime. Second, energy. Some physicists theorize this highly advanced process called Penrose extraction. This could potentially allow future civilizations to harvest energy right from the spacetime swirling around a black hole. We're talking potentially unlocking unlimited power. Third, our origins. The Big Bang itself started as a singularity, an infinitely dense point, just like the center of a black hole. So by understanding one, we get much closer to understanding how our entire universe was even born. And finally, the most mind-bending point of all, the math actually allows for black holes to be gateways to alternate dimensions, or, believe it or not, even time travel. We have to keep exploring this just to figure out what is truly possible. Section 5. The Future of Discovery. Reading the Stars. The crazy thing is, we are actively entering a golden age of astronomy right now. With incredibly powerful new tools like the James Webb Space Telescope currently out there hunting the oldest black holes in the universe, here's exactly what scientists are expecting to uncover in the coming decades. For one, we're going to see far more detailed photographs, which will give us an even closer, clearer look at exactly how light gets swallowed. We're also detecting gravitational waves from black holes literally crashing into each other and merging in real time. We're even on the hunt for primordial black holes, these miniature, ancient black holes left over from the absolute dawn of time itself. Science textbooks are literally being rewritten as we speak. So as we wrap up today's explainer, I want to leave you with this one really provocative thought. Are black holes gateways? Are they cosmic factories, or are they something else entirely, something we haven't even begun to imagine yet? They represent the absolute furthest frontier of human knowledge, the exact places where space, time, and light literally break down. And it seems like the more we learn, the weirder the universe gets. Keep questioning, keep learning, and I'll catch you in the next explainer.